I welcome you back. To the online tutorial. This is the Christmas edition. So we continue with the item 9. Item 9 says that item 9 says that a metal fabrication plant uses ethylene gas in its uses ethylene gas in its ethylene flame because it produces a very hot and clean flame, ideal for cutting thick steel plates. The ethylene is generated on site by dehydrating ethanol using concentrated sulfuric acid. During routine monitoring, the plant technicians carry out a pilot test in which 230 grams, we are given 230 grams of ethanol, is reacted according to this equation. So we have 230 grams of ethanol. What do they want? We also have this information in the bracket. The factory manager now wants to know how many molecules of ethylene gas were produced and further the total number of atoms contained in that ethylene. So using the information above, determine Roman 1 molecules of ethylene produced. So this is somehow similar to what we have seen in the previous item. So for Roman 1 molecules of ethylene produced, given 230 grams of ethanol, 230 grams of ethanol, and also this equation. So you see that the equation says that 1 mole produces 1 mole. The reaction ratio is 1 to 1. We shall use that somewhere. So proceeding with our response, item 9, Roman 1. So we are given mass of ethanol. We convert mass of ethanol to moles of ethanol. Then use those moles of ethanol and the given equation to find moles of ethylene. Ethylene is the same as ethene. Don't get confused. It is the same as ethene. Then convert moles of ethylene to molecules of ethylene. So we start with converting mass to moles of ethanol. So number of moles, we use number of moles is equal to mass of ethanol over molar mass of ethanol. The mass of ethanol provided, those are 230 grams over molar mass. We calculate molar mass. C is 12, but there are 2 of them. So 12 times 2 then plus H is 1, but there are 5 of them. 1 times 5 plus capital O 16 plus 1. So this gives 230 over 46. And computing this, we obtain 5 moles of ethanol. Then we convert these moles of ethanol to molecules of ethylene. What do we do converting from moles to particles, converting from moles to molecules? We use the mind map says that we use the Avogadro's relation. The Avogadro's relation says that, before that, these are moles of ethanol. Sorry. These are moles of ethanol. So we have to obtain moles of ethylene. We haven't obtained moles of ethylene. Sorry for that. We are just here on moles of ethanol. So we convert moles of ethanol to moles of ethylene. Using the concept of mole ratio, we compare ethanol to ethylene. The reaction says that if you look at that equation back, it says that 1 mole produces 1 mole. 1 ethanol produces 1 ethylene. Therefore, reaction ratio is 1 to 1. 1 mole produces 1 mole. Then what of the 5 moles? The 5 moles of ethanol which we have obtained, this will produce 1 times 5, and this gives 5 moles of ethylene. So we have used what we have to obtain what we did not have, the moles of ethylene. Now we have them. So we convert the moles of ethylene to molecules of ethylene. What do we apply in that case? We apply Avogadro's relation. 1 mole is equal to 6.02 times 10 power 23 molecules. Then if 1 mole is equal to those molecules, what of 5 moles? 5 moles will equal to 5 times 6.02 times 10 power 23 molecules. And this gives, calculating this, we obtain 3.01 times 10 power 25 molecules of ethylene. So this is item 9, Roman 1, approach 1. Then we also look at approach 2, the technical approach. Technical approach, you use the given equation directly. The equation says that on the left-hand side, you start with what you have. We have ethanol. So we start with what the equation says in terms of ethanol. The equation says that 1 mole of ethanol produces 1 mole of ethylene. But we have mass of ethanol. Since we have mass of ethanol, 1 mole of ethanol is equivalent to molar mass. Therefore, in that case, we calculate molar mass of ethanol. 12 times 2, capital C is 12, but there are 2 of them. 1 times 5 plus 16 plus 1 grams of ethanol. These produce 1 mole of ethylene. Now here we want molecules of ethylene. So we substitute what 1 mole represents in terms of molecule, and that is 6.02 times 10 power 23 molecules of ethylene. Then what of the, no, we substitute this, we compute this. This is 46 grams of ethanol. Now these grams of ethanol produce 6.02 times 10 power 23 molecules. So if 46 produces these molecules, what of 1 gram? 1 gram will produce 6.02 times 10 power 23 over 46 molecules of ethylene. What of the 230 grams in question? This will produce, so we multiply our fraction with 230, and these are molecules of ethylene. Therefore, we obtain 3.01 times 10 power 24 molecules of ethylene. So this is item 9, Roman 1, and allow me first stop here.